All right, so we're going to go ahead and look at the mole. Our goal here is to introduce the mole and examine how it actually relates to the chemical reactions that we just spoke about in the last unit. So taking a moment, of course, in your notes, your guided notes, you want to go ahead and rank yourself. Where are you at in terms of this information? 0 to 1, have no idea what's going on. 2, I think I might know just a little bit. 3, I got it. 4, I should move on from this into something a little bit more different. Now, I want to start off with the basic information. You notice some of the things that are written in red. These are some of the things that you want to write down in your notes. Now, the mole itself is a counting unit, just like a dozen or, let me say, a pair or a gross. It's a word or a term that means some actual number and makes it easier for us to actually be able to measure it. So, in this case, there's only one difference. We're dealing with a mole, we're dealing with a very large number, 602 billion trillion. As you see, that's a whole lot of zeros that we'd have to deal with there. Now, to simplify this, we wrote it in what's called scientific notation, which is just the way so that scientists can be lazy and still write all the same information. So it's 6.02 times 10 raised to the 23rd power. If there are any questions on how to plug that into a calculator, make sure and see me and we'll go ahead and get that taken care of. Now, this is all named in honor of this guy named Amadeo Avogadro. His name almost sounds like avocado, so it makes it a little bit easier to remember. Now, this number, this 6.02 times 10 to the 23rd power number, is what we call Avogadro's number. So you want to make sure you remember this, write it down, circle it, highlight it, big flashing lights, because this is important. Now, to give you an idea of how large a mole is, there's only one of these I'll actually share with you. The other ones, if you'd like, you can pause it and come back and read them. But in terms of time, time is precious to all of us. But if we looked at it, if we were able to count at a rate of 10 million per second, 10 million atoms per second, it would still take us 2 billion years to count the number of atoms in one mole. So we're dealing with this huge, huge number to represent something that is so small that it's very hard for us to actually manipulate with our hands. Now, a few basic facts to look at. Just like if I have a dozen cookies, we're going to have 12 cookies. So a mole of cookies in that case would be 6.02 times 10 to the 23rd. Same with cars. A dozen would be 12 versus a mole of cars would be that large number 6.02 times 10 to the 23rd. Now, the main reason why we want something like this is it's very hard for us to work individually with an atom. We can't pick it up, we can't manipulate it, we can't see it, we can't touch it. But if we have one mole of atom or this large number of atoms, it's something that we can actually measure on a balance or work with and do chemical reactions. Now, notice that each time it's the same number, but the key difference here is going to be that the mass of each of these substances is very different. If we had one mole of cars, it would definitely be much larger than a mole of cookies, even though cookies sound really good right now. But we'll go back to that another time. Now, last thing to write with this, the mole is going to be abbreviated MOL. And while right now it seems like that's not really that much shorter, as you write, you'll find that it actually saves you just a little bit of time. Now, keeping with the same idea of what we had here, we have a mole of particles contains 6.02 times 10 to the 23rd particles. Particles can mean a couple of different things, though, so we want to pay attention to this. One, if we have a mole of atoms, it means that of carbon atoms in this case, it's 6.02 times 10 to the 23rd atoms. Or if you look in our second example, we also have molecules that can be included, or, and this is one that we'll use instead, formula units. Formula units just means that we're dealing with an ionic compound that is not technically bonded. Remember, we just said that they're attracted, and so that's what's causing them to actually stick together. Now, in this same saying, we could say that since these are formula units and they're not exactly bonded, we have the same number of sodium ions as we do chloride ions. So 6.02 times 10 to the 23rd. Now, in order to do these types of conversions, we actually need to look at something called a conversion factor. Now, conversion factor is just an equality that's used to compare two different units. Many times when we go into, say if we like to cook or whatever it is that we like to do, we go into the kitchen and we say, okay, I have this many ounces. How many teaspoons or tablespoons is that? Or how many gallons would that be? And we use that information to make whatever product it is that we were trying to go for. Some examples that we use on a regular basis is, everyone knows there are 60 seconds in 1 minute or 12 inches in 1 foot. So we use these things all the time. Even in your mind right now, you could probably say, okay, well, I am 5 foot 9 inches, so how many centimeters would that be, or how many feet is that? And use that information in different ways around us. Now we're going to do the same thing using our equality for our mole. Now, because of the fact that we can throw this in there, and I wanted to make sure this example is given. If we have any number over itself, we know that it equals out to 1. So no matter how large the number is, 750 divided by itself will still give us 1. We want to take the same information, and now we're going to apply it to our conversion factors. Meaning what? If I had 60 seconds like we just said before, and we said 60 seconds equals 1 minute, even though the units are different, I should be able to say 1 minute divided by 60 seconds still equals 1. So in our multiplication or dividing, I'm changing the unit, but I'm keeping the number the same. This is what we're going to use to continue to go through this. Now, our conversion factor that we'll use here, though, will be our Avogadro's number. So we're either going to use the 6.02 times 10 to the 23rd over 1 mole, or 1 mole over 6.02 times 10 to the 23rd particles. Again, making good note that our particles could be atoms or molecules, forming units, or ions. Now, at this point, you want to switch over to the next video where we're going to actually go through how to set up and complete these conversions. I'll see you in class tomorrow. Make sure you bring your questions, and we'll be ready to go from there. Have a great day.